What up, physics students? Here's what we're gonna do today. I spent 2 days on vectors with you guys. I think it was Monday and Wednesday, and I feel like that was pretty good lessons. What do you guys think? Was that good for you, or yeah? All right, you feel good about it? Um, I don't have. What I'm gonna do today is I'm really ahead of schedule because I think that your last vector homework is due on like the 24th. So in like 3 weeks. So we're good as far as like being caught up with lecture and whatnot. What I'm what I'm going to do for you today is I'm going to do some of your homework for you. I'm going to go through your homework and I'm going to find one problem from each homework in vectors and we'll do them. We'll do them together. And then on Wednesday, we will hopefully be able to move on to two-dimensional motion. I think that would be a cool lab to do. We cool? So I'm not going to move on to two-dimensional motion because we don't need to start with that until March. And I'm not going to like compress your homework because it's so easy and everything because I'm giving you a lot of homework, which is good because I think that it will give you a lot of good practice. But what I need to do is, also take a look at your homework with you. All right, so let me look through your homework, and I'm going to choose one problem from each homework assignment. So I'm going in 3.2, the section on vectors. We will do problem number, 1 second, it's pulling up. Let's do problem number 2 together. That one looks good. All right. So this is vectors. All right, here we go. All right. So it says, all right, here it goes. A lighthouse rises 49 feet above the surface of the water. Okay, we've got the water here, or here's the lighthouse. Here's my water, and this guy is 49 feet. The lighthouse is 49 feet above the surface of the water. And then it sits on the edge of a rocky cliff that it stands 19 feet above at its base. So apparently, this is 49 feet, but the cliff is 19 feet. Got it? All right. And then, let's see. A sailor at the top of the deck sights the top of the lighthouse to be 30 degrees above the horizontal. But the sailor is 14 feet above the water, because here's the boat. So the sailor is 14 feet above the water, and he looks at this thing, and it's 30 degrees. We cool with that? How far is he from the rocks? Oh, I was wondering what it was talking about. I don't think that's 19 feet. I think this is 19 feet. We cool? All right. So, let's see. Do you see a triangle? Because this vector stuff is all about triangles. This is question number 3. This is 3.2 number. I'm going to call it number 10. And if you look on the homework, there's a dark number that is, it's question 10, even though it's only the third question presented to you, because the textbook says it's 10. All right. I see a triangle, and here's the triangle that I see. You guys got it? All right. That triangle is, let's see, it's 30 degrees here, 30 degrees. And how tall is this? I'm just redrawing this triangle over here. Yeah, no, you totally know how tall it is. Come on, Kaylin, can you figure this one out? How tall is it from here to here? $35 feet? How'd you get that? I'll tell you what, Kaylin and Ethan, can you guys turn on your mics and why don't you guys just talk to me? Turn on your microphones so you guys can talk if you want. All right. Yeah, exactly, Ethan. It's 49 minus, yeah, so that's 35 feet. We cool? All right. So I have the opposite side and I have the adjacent side. And what I'm looking for is the adjacent side. Right here, A. We'll call it A. So how do I find, what trig function do I use if I have my opposite side, I got my angle, and I'm looking for the adjacent side? Is it SO, CO, or TOA?
So?
Okay. Ethan says so, and I disagree with you. So is sine is opposite over hypotenuse.
Okay.
I'm looking for adjacent, so it has to have something with an A in it.
I haven't done this in so long. Is it TOA?
There we go. It's tangent of theta is opposite over adjacent. Yeah, exactly.
Okay.
Ethan, you weren't here for the last 2 lectures?
No, I was not.
Oh, okay. Were you? But you've learned this before.
Yeah, I've done cosine, adjacent, and sine before.
All right, I'm not going to go through it slowly like I did in the last 2 lectures, but I would really encourage you to go and check out the last 2 lectures. I think that I basically introduced it as if you never looked at it before.
Oh, cool. Okay.
Yeah, so watch those because that will probably really help you out and solidify your understanding of this. Now, I don't know if I uploaded the second lecture, but definitely go check out last week Mondays. Cool? All right, but yeah, you're right. It's tangent. Man, these marker sucks. Sorry. It's tangent of theta. Tangent of theta is opposite over adjacent. Cool?
Yep.
And that's not a 0. If it's a 0, I'm going to put a slash in it, by the way, just so we don't get confused.
Alrighty.
So I probably should put a slash there and a slash here. All right, so the tangent of 30 degrees, so I want to figure out what A is. A is equal to 35, which is my opposite, right? Divided by tangent of 30 degrees. Does that make sense?
Yeah.
Do you have a calculator or do you have a phone that uses a calculator or what?
Yeah, I do.
All right. Tell me what 35 divided by tangent of 30 is. Kaylin, throw it out there because you were using your phone and your phone was acting some funky, giving me some funky numbers. So I want to make sure you can do it too. Let me go find my calculator. I think I left it outside.
I was thinking $10.
So when you're putting 30 degrees in the calculator, do you have to put a degree sign at all, or can you just put 30?
Are you using a calculator?
Yeah, I'm using a calculator.
Is there a mode button anywhere?
Well, I'm actually able to press tangent and everything.
Are you using a phone or a calculator?
I'm using a Texas Instruments calculator.
All right. Is it a graphing calculator?
Yeah.
All right. Right around here, right around the top row, there's a
Okay.
button that says mode.
All right.
All right, click on that button that says mode.
Okay.
Then what you're going to do is you're going to probably see deg, rad, and grad. You'll probably see like norm, sign, English, and then
Yeah, okay.
underneath that there's deg, rad, and grad.
Okay, hold on. I'm seeing the normal, science, and English.
Yeah, that. Then there's the or you might even see degrees, radians, and gradients.
Yeah, that's what I'm seeing.
Okay, all right. I see deg, rad, and grad. Yeah. Choose degrees.
Okay.
So make sure you choose that, and then what you do is you quit it by pressing second and probably that mode button again, and that will get you back to the home screen.
Okay, perfect. And then I don't have to do degree?
No, you don't have to do the degree symbol.
All right, I got the answer.
All right, so what did you get?
I got 60.6217.
Yep. So apparently this dude is 60. This number is 60.62 feet or meters or whatever it is. I'm not sure. It's feet. Feet. Cool?
Yep.
So how far is the sailor from the shore? Because he's 60.62 feet from the lighthouse. But the shore, the lighthouse is 19 feet behind the shore, the cliff line or whatever.
So you'd have to add 19 feet?
You think add?
Or subtract? No, you'd have to subtract because it's coming into the triangle.
There we go.
Alright, so it'd be like... Hold on, let me do this.
And let me just double check to see what, let's see what we got.
41.62.
41.62. I would put down 42.
Okay.
And that should give you, apparently, yeah, that's the right answer.
Cool.
All right. Does that make sense to you, Kaylin? So what I'm going to do is I'm going to go to the next homework, and I'm going to choose a moderately hard problem, and we'll see what we can do with this.
Alright, sounds good.
Magnitude of displacement. All right, let's do this one. This one's good. Okay, all right, here, we'll do this one. Let's do this easier one first. So let's do section 3.3, number 21. All right?
Alright.
An air traffic controller observes two planes approaching the airport. The displacement from the tower of plane 1 is vector A. Or by vector A is 220 kilometers and points 32 degrees north of west. So, here's my air traffic controller, and 32 degrees up from west. West is that way. So up from that is 32 degrees at 220 kilometers. Yeah, that's what it says. All right, cool.
All right.
And then the displacement from plane 2 is vector B, and that's 140 kilometers, 65 degrees north of east. So, or 65 degrees east of north. Oh, that makes a difference. So this is 65 degrees. Because if it were north of east, it would actually be this angle right here. But it's east of north, so I got to start with north, and I got to go 65 degrees east of that. Does that make sense to you? And apparently he said 140 kilometers.
All right.
Are we cool? Kaylin,
Yeah.
Can you hear? All right. So, sketch out thing. Find the. All right. So here's what I want to do: is vector D is goes from A to B. Vector D is a vector that points from A to B. Got it?
Yeah.
And it looks like it's horizontal, but it's not horizontal. You can't assume that. So before we even start this problem, I'm gonna do this. I'm going to break each of these vectors. Let's erase vector D for now. Before we even start this problem, I'm going to break each of these vectors into their components. And I'm going to figure out what each component is. I don't even know what they want me to do yet, but I'm going to do that. Are we cool?
All right.
Because this is the game that we're going to play over and over and over again. You're going to get so darn good at this that you'll be able to kind of just take this thing out. All right, so I'm going to call this vector, see this vector right here? This A vector?
Yeah.
I'm going to break them up into two parts, an X part and a Y part. So I'm going to call that X part AX, and this one will be AY. Are we cool?
Yeah.
All right. AX is the adjacent side to the angle. See, here's the angle. The adjacent side is AX. I know what A is. A is my hypotenuse. It's 220 kilometers. So which trig function would I use that deals with adjacent and hypotenuse?
So it'd be cosine.
Yep.
Right.
Yep. Because it's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There we go. Exactly, Kaylin. So the cosine of theta is equal to AX over A. Adjacent over hypotenuse.
Okay.
So AX is equal to A cosine theta. Are we cool with that?
How did you get that?
I multiplied both sides by A.
Okay. Yeah, that works.
You happy with that, Kaylin? All right, cool. AY, on the other hand, is equal to... Can you tell me what that is right off the bat, or do you need me to go through that same exercise?
Oh, no, I got it.
What is it?
It's the what is it called?
Kaylin, you can answer as well.
It's O.
It's the opposite side, so which trig function do I use? I would use so, right? And
okay.
Basically going through that same argument. In fact, I'll do it for you. Sine of theta is equal to AY over A. Right?
Okay.
So that tells you that AY is equal to A sine theta. Same kind of deal with the cosine.
I see how you're doing with that. I just don't see how this is going to help.
All right. I'll show you how this will help. I didn't even tell you what we're looking for. But I'm telling you that whenever you see a vector that's at an angle, in physics, break it up into its components, into its X and Y components right off the bat.
Okay.
All right? Because, yeah, if you get used to doing that, then chapter 4 is going to be cake for you. And then even like forces is going to be easy for you. You have to be able to do this thing so quick. You can look at this thing and say, oh, that's AX cosine, AX equals A cosine theta. By the way, that's 220 times the cosine of 32. Hey, can you plug that into your calculator? Tell me what that is.
Yeah, 1 second.
Kaylin, can you do 220 times the sine of 32?
All right, it's 186.5705.
You got 186
Yeah,
times cosine of 32. Yep, I got 186.
cool.
Kaylin, what did you get? 121. I got 116. Actually, 117. And then not 186. I got 187 because it's 186.57, whatever.
Yeah.
Kaylin, you got to double check your calculator. Make sure you're doing it or you got the right mode and whatnot. I got 116.5822381, whatever. So, all right, we're cool with this though.
Yeah, that's cool.
All right, and then for this one, I'm gonna label this thing BX, and this one, I'll label this one BY. Are we cool with that?
Yeah, that makes sense.
So, BX is equal to what?
A, right?
Nope.
Or
No. Think of this as a triangle. Here's your triangle. Here's B. Here's BX. Here's theta.
that's opposite.
Yeah. I'm glad you caught that. So sine of theta is equal to bx over b. So bx is equal to b sine theta. Are we cool?
Yeah.
Now, the reason why I'm glad you caught that is because usually we give the angle going from here to here. And then what happens is a lot of people would just think, oh, okay, bx is b cosine theta because they think, oh, ax was a cosine theta. You see what I mean?
So
But,
yeah,
But
but it's all if it's on the bottom, right?
right, it depends on where you call the angle. If the angle is down here, then this is no longer the adjacent side. This is the opposite side.
Yeah.
And this is the adjacent side. So you would use different trig functions. You have to be careful with depending on what you're talking about. So by is equal to, are we cool if I just say it's b cosine theta?
Yeah, that's cool.
All right. So tell me, what is bx equal to? Bx is 140 times sine of 65.
Uh, 126 or just 127.
127, and then what about b cosine theta? Kaylin, are you coming in on Wednesday? If you are, then we'll sit down and definitely learn how to change your thing. This homework, I don't think is coming up until like 2 weeks from now.
This is the other one's 59.
59? All right, 59. All right. So here's what the question ended up being. So before I even knew what the question was, I broke a vector up into its components, and you're wondering, why the heck did you do that? That just added so much work, and we haven't even started the problem yet. Well,
Yeah.
Because that's all the heavy lifting. The rest of the problem is going to be cake, I promise you. The actual problem asked you, well, how far is plane A from plane B? Okay. Well, here's plane A and here's plane B. How far is that? Right? It's this distance from here to here.
Totally.
Okay? So, what I want to do is, this is distance D or whatever. Are we cool with that?
Mhm.
And I can break even that into its components. This would be dx and dy. What is dx equal to?
187.
Nope.
Wait,
Close.
hold on. Oh wait, no, sorry, I'm thinking. It's 187 plus 127.
Right, because dx is from here to here. I know the x component of this is 187. I know the x component of this is 127. So dx is the x component of both of them.
Totally.
Does that make sense?
Okay, that makes sense.
So, like I said, once I broke this vector into its components, solving the problem was cake. Well, I'm not done solving the problem yet. Can you tell me what dy is?
dy is hold on, let me relook at what we were just doing. Dy is 117,
Okay.
I think.
Nope. Not just 117.
Plus 59,
Half.
or maybe
Half. Correct.
minus. Yeah, minus 59.
Why? How come?
Because they're not the same height.
Yeah. This thing goes up higher, actually. I probably should have drawn it like this. So,
Yeah.
so my d vector is a little triangle that goes from here to here, and the height is, this thing went up 117, but this thing's up 59. So what I really want is the difference between that point up there and there. Does that make sense?
Okay, yeah, that makes sense.
So what is 117 minus 59?
58.
All right. So this is actually 58, and this is actually 309. So what is my distance? Do you know how to figure out this length right here if you have 58 and you have 309?
It's cosine.
Nope.
Oh, it's just a number. Hold on, let me put this in.
There we go. Kaylin's got it. Check out the chat.
Okay.
Right, because you got a right triangle here. Here's A and here's B. To get D or C or whatever you want to call it, it's A squared plus B squared equals C squared. So 58 squared plus 309 squared, the square root of that, that's your answer for D. Are we cool with that?
Yeah, that's a really big answer.
No, it's probably going to be like 320 or something like that.
Huh.
Actually, I'm looking at exactly the answer. It's 320.
Okay.
I just guessed it, but yeah, 320. All right. Now, here's another question I can ask you is, what's the angle between, because all you did was you gave me a magnitude. You gave me the distance between these two planes, right? But what's the angle in between these two planes? What is the direction of vector D? And what I'm looking for is this angle right here. We cool with that?
I'm not sure.
Well, I'll tell you. To find that, it's actually really easy. We're looking for this theta right here, okay? We have an opposite length right here. We have an adjacent length right here. We can use trig. Oh. Which trig function can we use?
Cosine?
No, come on, dude. I was pointing to this the whole time. It's tangent, yeah, completely tangent. The tangent of theta is opposite over hypotenuse. No, opposite over adjacent. Are we cool?
Yeah.
So theta is equal to the tangent inverse of 58 divided by 309. I'm going to ask you to do that. Okay, put that into your calculator. Tell me what you get, because I want to know if you know how to use a calculator correctly. What's going on, Maston? Yeah, I'm still sick. I'm coughing up some lungs. Maston, you can turn on your mic, and then it'll be a party up in here.
I got a really low number.
What you got?
0.0032.
Nope, you did it wrong. Here's what I got.
All right.
All right. You want to see how I plug it into a calculator?
Yes, please.
Okay, I press the tangent button is this one right here, but I'm not looking for the tangent button. I'm actually looking for the tan inverse button. It's that green one
Yeah.
right there.
Okay.
So I press second, and then that one, and then that gives me my tangent inverse. Then I just straight up type in 58 divided by 309.
Is that how? Did I do it?
What is that?
Did I do it? Mike?
Yeah, you're on the mic.
There we go. Okay, good.
Anyway, yeah.
All right, yeah, I figured that out.
Kaylin's asking, why did I use the inverse tangent? Well, because I have tangent of theta is equal to my number, but what I really want to figure out is I want to get theta all by itself. Kaylin, in the previous problems, we were solving for O, or we were solving for A. And so we basically just said, okay, well, O is equal to A times tangent of theta. But what I'm trying to do here is I'm trying to figure out what theta is, and so I have to peel off the tangent. In order to peel off the tangent, I have to take the tangent inverse of it. Does that make sense? It's like tangent is guarding my prize. So how do I get to that prize? I take the tangent inverse of both sides. Then that will take off this thing, and then your theta is all by itself. We cool with that? Now, I don't know if you learned that in wherever it is you learned SOHCAHTOA. But you should have. And it's good. It's good that I'm going through a bunch of these with you, because maybe you might not have known that technique. I have time to maybe do one more problem with you guys. Let's see.
I had a question about the homework for today too. When you're done.
All right. Why don't I do this? Why don't I do one more of these problems for you, and then we'll take a look at some of your homework. I'm going to do section 3.6, number 54. Oh, this is a good one. All right, this is talking about relative motion. All right, here we go. A passenger walks from one side of a ferry to the other side as it approaches the dock. If the passenger's velocity is 1.5 meters per second due north relative to the ferry and 4.5 meters per second at an angle 30 degrees west relative to the water, what is the magnitude of the ferry's velocity relative to the water? Okay, let's see. What the hell? Okay. north, 30 degrees north, west of north. Okay. All right. So a passenger is on some kind of ferry. I'm looking down on this guy. And apparently he's walking north at 1.5 meters per second. Are we cool?
Yeah.
And what actually, so according to the passenger that's on the ferry, he's only going north. I'm only walking north on the ship. But what the bird actually sees is the passenger traveling like this, 4.5 meters per second at 30 degrees here. Does that make sense?
Yeah.
So apparently the barge must be, or the ferry must be moving that way. That's what I'm thinking. You get it?
Yeah.
It must have some kind of velocity that way. It's kind of like if you are driving inside of your car, all right? So here's your car, and you're driving inside of your car. Think about this. If you're driving inside of a car and you take a tennis ball and you throw it straight out the window, all right? What are you gonna see? Ignoring air resistance.
It's gonna kind of make a curve, right?
No, it's just gonna go straight out like that. That's it.
Avoiding air resistance.
Yeah, no air resistance. So it's just going to go out. That's all you're going to see. You're going to see it go out from you. Just throw it out the window. You're driving forward, it's going out
if there is no air resistance.
Right, no air resistance. We're not talking about it curving back or whatever. So you're just throwing it out.
That's what I thought you were getting at.
But what would a bird see if it were looking down at you? Well, it would see it going like that, right? Because if you're driving in this direction, it will see the thing going kind of like that. Does that make sense?
Yeah.
Yeah.
All right. And then the slant of this thing really depends on how fast you're going. If you're going faster, then it's going to be more slanted. And if you're stopped, then it will actually be straight up like that. Does that make sense?
Yeah.
So this is what's going on. Anyway, what we want to figure out is what is this length right here that causes that. Okay, so this is actually kind of an easy problem, to be honest with you. What I want to find is I know that this component plus this component should give me this thing. I know this thing is 4.5. I know this is 30 degrees. I know that this is 1.5 meters per second. Shoot, I don't even think that I need the 1.5 meters per second. I don't think I even need that piece of information. Because look, if I take the sine of 30, that gives me this opposite side over the hypotenuse. Does that make sense?
Yeah.
What I'm trying to do is figure out what this length of this arrow is. Well, and I don't like calling it O. I'll call it OP. I'll call it OPP. You guys get it?
The original post-it.
Yeah. So to solve for OPP, I just say OPP equals 4.5 sine of theta. What is 4.5 times sine of 30 degrees?
Let me get my calculator.
Ethan's got it.
2.25.
What is it?
2.25.
2.25. 4.5 times sine of 30.
Wait, are you doing it or do I need to pull up my calculator?
What is that?
Are you doing it or do I need to pull up my calculator?
No, I'm doing it.
Okay.
Um,
Don't trust my calculations. I see how it is.
no, you can use your calculator. I just didn't know if you had
I'm
it.
just messing with you.
What is the direction and magnitude of the ferry's velocity relative to the water? Oh, I see. Okay, wait a second. Here's the problem that I have. That's not the answer. And
Okay.
here's what I'm thinking is, let's see, how do we do this problem? Here's the problem that we have is that's not the answer, and this is why it's a double star problem. It's an extra hard problem. It's because stupidly I assumed that this ferry was going only at only to the right. Does that make sense?
Mm-hmm.
But it didn't say
Yeah.
that. It didn't say anything about that information. It didn't tell me, oh, this ferry is definitely going only to the right. This ferry could be going this way. Does that make sense?
Mm-hmm.
So now that adds an extra complication to it. All right, fine. Let's do it this way then. I know that. Oh, okay. Okay, here's what I need to do. I know that the angle or the vector here, this north vector right here, plus my vector over here, that's the ferry vector, has to equal to the vector that the bird sees, the resultant. So this is 1.5, this is 4.5, and this is 30 degrees. Are we cool?
Yeah.
And so what I have to do is I got to figure out what this is.
So can't we just do the Pythagorean theorem again?
No, we can't use the Pythagorean theorem because Pythagorean theorem only works on 90-degree triangles.
Alright.
This, my friend, is not a 90-degree triangle. I can't tell what it is, but you know I can definitely. I don't know even if it is 90. I don't think it is. But here's what I would do: is I see a vector 4.5 at an angle. Is it right with you if I say okay, let's figure out if that's r, then I'm going to make this one rx and ry. We cool?
Alright.
And then r is 4.5. So rx, if this is theta over here, then would you guys agree with me that this is theta over here?
Mm-hmm.
And so rx is r sine theta, and ry is r cosine theta.
Yeah.
Ethan and Kaylin, I figured you guys would catch on to that real quick. Maston, I'm not sure how long you were here, so I don't know if you can see this right off the bat.
Oh yeah, I've seen this stuff before.
All right.
It's just kind of like a recap.
Ethan, are we good?
Yeah, that makes sense.
All right, so this is 4.5 times sine of 30 and 4.5 times cosine of 30. Maston, give me ry. Ethan, give me rx. Kaylin, hang out. We got to figure out how to use your phone.
Alright, I got it.
All right, what is it?
2.25.
2.25. Maston, what'd you get?
1 second, I'm pulling up my calculator. You said I wasn't gonna need it. Give me a second. What was RX?
I want you to calculate ry, and that's 4.5 cosine of 30.
4.5 cosine 30. Where's the cosine? There it is. Found it. I think my calculator did it wrong.
All right, fine. Ethan, what is it?
3.897.
3.897.
Or never mind, it didn't.
All right. So check this out. Here's how we do this problem. Is we know that this thing goes up 1.5, and we know that I can replace this vector with one going 2.25 this way and 3.89 this way. We cool?
Yeah.
So what I want to figure out is so after I broke that vector up into its components, what you're telling me to figure out is this thing right here. Let's call this, I don't know, F, as in fairy. Got it?
So you'd minus them together?
Minus what?
3.89 minus 2.5, 2.5 or whatever.
Nope, not 2.5. 3.89 minus 1.5. That will give me my Fy.
And then I need to do 1.5 minus 2.25 and add those together.
No, you don't even need that. All right, so see this vector F right here? I'm going to call this guy Fx and Fy. What is f of x?
2.25.
Perfect. What is f of y?
3.89 minus 1.5.
Perfect. So that's your f of x and f of y. If I want to figure out what f is, what can I do?
The Pythagorean theorem.
There we go.
So
Right.
it's okay.
And that gives you your magnitude. We're cool?
Yeah.
This
You need
one's,
to find a better calculator, though.
this one's a tough one. This one's a tough problem. What kind of calculator you got? I got this for like $6 at Walmart, I think, and I got that on.
I have www.google.com.
No, that works. That works perfect.
Is it? Okay, I'll just keep using this. Maybe
Type
I
in
did something wrong.
4.5. Type in 4.5 cos, and put in parentheses 30, and then type in degrees. That's what you forgot. You forgot the degrees.
Ah,
Because
yes.
Google automatically assumes you're dealing in radians, and you need to tell it, hey, I'm dealing with degrees here. Got it? All right.
30.
I have time to field your question, even though technically I'm overtime.
Degrees. There we go. Yeah, there it is.
All right. So I have time to field your question, even though I'm overtime. What's your question?
Yeah. So for the homework today, there's this one about. Let me get to it. It asked for an equation.
Yeah.
It says for the equation, but I just gave the solution and it was wrong.
What is the problem? What number?
Which one was it? Part B.
Which homework is it? 2.7, 2.6?
Yeah, 2.7, 1D motion, part B.
1D motion part B. Okay. Here's part
Yes.
A. Here's 2.
And it was question 4.
Does it have a question 91 next to it?
No, 92. Oh, yeah, 91.
All right. Standing side by side with your friend, you step off a bridge at different times and fall for 1.6 seconds into the water below. Your friend goes first, and you follow after she has dropped 2 meters. Verify the answer to part A with a calculation. Or when your friend hits the water, is the distance between you more or less? Oh, I see. So you want to calculate how far it is you guys are when you guys hit the water. Is that what you're saying?
Yeah.
So
let me grab my piece of paper that I worked on here.
all right. So here's what I would do. I would say I would draw the picture with a pen that works. Oh no, all my pens suck. All right. So you got time equals 1.6 seconds. You don't have the height. You don't know it, but you can figure it out. That's pretty easy to do. In fact, let's figure that out. Um, we have gravity. We know that is to be 10 meters per second squared. We know our velocity initial for everyone is 0 meters per second. And we know our, we don't really care about our V final. But for now, let me just figure out what the height is. Cool? So the way I solve physics is, and I think that I've been kind of, Ethan was kind of asking, well, why the hell are you breaking those vectors up into their components without even reading the question? And as you do more and more of these, you get more and more creative, and you get better at them. But and I'm able to look at a problem now, and I've been doing physics for almost 20 years now. I'm able to look at a problem now and to basically just say, okay, this is the approach I'm taking. But from you guys don't necessarily know that because you don't have experience. So what you guys will have to do is just start solving for things. You know, like, man, I'm stuck. I don't know where to even go with this problem. Why don't we just warm up with solving for things I can solve for? And maybe...
Well, yeah, I got... Because, like, I know it's more than 2 meters, but I have no idea what the calculation would be for me to prove it.
All right, well, let's figure this out.
Okay.
Let's see. All right, here's what I'm curious to know about then. Is, how far did she fall? Did your friend fall? Is it her, or does it matter?
I don't think it matters.
All right. How far? Oh no, it says she. So you're jumping in the water with a friend, a female friend. That's cool. And how far did she fall, or how long did it take when she fell 2 meters? So that's pretty easy to do.
2 meters, that's 0.64 seconds.
V naught, well, shoot, you did that without me even doing any calculations.
Yeah, because I did that. I did that already on my piece of paper.
All right, fine. Let me do it then. Delta y
right.
equals V naught t plus 1/2 at squared.
I'm not that gifted.
I'm calling down positive y direction. So I've got 2 equals V naught is 0, 1/2 10 times t squared, and I want to solve for t. And so what you did, like 4 over 10 square root equals t. So t, what'd you get? 1 point what?
I got 0.64 seconds.
0.64 seconds. So here's the thing.
I used 9.81.
All right, fine.
You used 10.
Fine.
No, you know how I am, don't I?
All right, yeah. Okay, cool. So how long did you fall? For how long did you fall when she hit the water? That's my question. So apparently you jumped 0.64 seconds after she jumped. How long did it take for you to hit the ground? Or how long did you fall for when she hit the water? Because she hit the water 1.6 seconds after she jumped. Does that make sense?
Hold on, say it again.
All right, so check this out. If you jump off this cliff, it only takes you 1.6 seconds to fall to the ground.
Right.
Well, let's assume it's water. So fall to the water. She jumps and she falls 2 meters, right?
Right. And that's 0.64 seconds.
0.64 seconds, and that takes 0.64 seconds. So then, at that time, you jump. Got it?
Right.
Now she falls the rest of the way. How long does it take for her to hit the water?
Theoretically, 0.96, right?
0.96.
Okay.
Cool, right?
Yeah.
It's 1.6 minus 0.64 is 0.96. So you're telling me you fell for 0.96 seconds when she hit the water. We cool?
I think I am.
All right. Well, you can figure out how far you went using this equation. delta y equals v naught t plus 1/2 at squared. Because you're telling me, like, if I were to step back and ask you the question, hey, Maston, you jumped off a building. You fell for 0.96 seconds. How far did you fall? You'd be able to solve that in a snap. Right?
Mm-hmm.
You would just say, well, I got to figure out what delta y is. V naught is 0. So that's just 1/2 9.81 times 0.96 squared.
Right.
So plug
We
that
did this in all of our labs.
So plug that into your calculator.
Right. Doing right now. Sorry it takes forever. I have to like switch tabs.
That's all right. Oh, and after looking at this, yeah, getting that height of the cliff is actually something we should have done as well. This is a good problem, though.
So 4.5.
4.5 meters?
Yes.
All right, 4.5 meters. I got a question. Do that same thing, 1/2 times 9.81 times 0.16 or 1.6 squared. I want to figure out
1.6 squared.
What is the height of the whole dang cliff?
$9.81 and divided by 2. I got 12.5. Well, 12.5.
12.55.
So you're going to have to.
All right.
Yeah, 12.5.
So the height of the cliff is 12.55. And
yes,
she fell to the bottom. Boom. She's the full 12.5 meters on the bottom. But when she hits the bottom, you are only 4.5 meters down.
Right.
So what's the difference between your height and her height? When does it say when she hits the bottom? Yeah,
8.
8. Yeah, 8. That's your answer.
Because that's more than. Oh. Hey, look at that. That's certainly more than 2.
Yeah, 8 is more than 2. For sure.
8 is more than 2.
Yeah.
Well, there we go. That was it.
And your answer is 8. And the answer that I put in is 8 with a margin of 1. So you could have put in 7 or 9 and you'd still be fine.
No, I didn't. I didn't even put in like anything. I was just like, what? And then so I skipped it and went ahead and did the others.
All right. So the gist of how we solved this problem is we said, all right, well, figure out how tall the cliff is. That's not hard, right?
No.
Then we said, all right, how long after your friend jumped did you jump? And then,
right. Yeah.
Then we said, oh, that's 0.64. And then we said, all right, then how long did you fall before she hit the water? Or until she hit the water. And so that would
seconds.
Yeah, and that would be the whole journey minus the journey that she's already finished. She's already gone. And then after that we said, well, how far did you go in that 0.96 seconds? Does that make sense?
4.5 meters.
The recap of the problem. So what we ended up doing was we ended up using delta y equals v naught t plus 1/2 at squared a bunch of times. We
just did it over and over again.
Well, yeah, but we were just using different variables because we were trying. But do you see the logic that I kind of go through?
Yeah, no, that helped me a lot, though.
But how do I teach it to you? I'm not sure. I think that you just do a bunch of these and you get creative after a while.
I think kind of just like chemistry.
Right, like how do I teach you creativity? No, it's not even. It's actually it's not even like chemistry. It's more creative than chemistry.
More creative than stoichiometry.
Yeah, for
Because
sure.
we just had to do that over and over again until we got it.
No, yeah, stoichiometry was just stoichiometry, chemistry. That's all just like calculation. You just have this like machine. You plug it through, and it takes these steps. Boom, 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 boom. I couldn't give you a step-by-step process on how to do that problem.
No.
I just had to take you through my logic, through kind of like, this is how I would go about it. And there's different logic for different things, but that's the beauty of it. You're not building, like you don't have all these billions of equations and you just choose which one. There's only 4 equations, but there's all these variations that we can do just to kind of throw in some ideas about, well, try to be creative about it. Try to think about it this way. Think about it in this light over here. You know what I mean? Physics, and that's what makes physics harder than chemistry. That's why I'm always saying physics is harder than chemistry, even though you guys aren't experiencing that yet. Well, it's because there's not this equation that you just kind of plug in and regurgitate out the answer. All right, anyway. I got to go. I'll talk to you later.
Yeah. All right. Hey, thank you very much, Dada.
See you Wednesday?
I will see you Wednesday, yes.
Okay, bye.